So we finished talking about the comparison between ionic bond and covalent bond. So remember, ionic bond is like getting a formal marriage. Covalent bond is like cohabitation relationship, because ionic bond is a complete transfer of your property to your spouse, but covalent bond is just sharing your properties with your partner. Now let's continue with the structural formula of the molecules, or the compound, which is called compound. So remember, methane gas is composed of one central carbon atom with 4 peripheral hydrogen atoms. And because hydrogen has only 1 electron, so it can only share the only 1 electron with carbon. But carbon has 6 electrons because it has 6 protons. The first 2 electrons of carbon is in the first electron shell, and then the other 4 electrons is in the second or the outermost electron shell. And each atom of the carbon will be shared with 1 hydrogen atom. And it will form a covalent bond because 2 electrons forms a bond. That's why you draw a straight line connecting the central carbon with the peripheral hydrogen atom. And we call it a CH4, which is a methane gas. Now, this is what we call a tetrahedral shape. Tetrahedral shape is like you're having 1 central carbon connected to 4 hydrogen atoms, but the distance between each hydrogen atom, they are maximized. When they're maximized, we call it a tetrahedral shape because each side is like a triangle, meaning that it is actually composed of 1, 2, 3, 4 equilateral triangles. And we call it a tetrahedral shape. This is called space filling model. That one is called ball and stick model. Space filling model is I would say, the closest to the real compound or the molecule. They call it molecular structure. This is the closest to the reality of the molecular structure. Now we need to talk about 2 new terms, polar and nonpolar. Polar and nonpolar only occurs in covalent bond because when we share electron, sometimes it is not equally shared, sometimes it is equally shared. When it is equally shared, we call it nonpolar. That is for covalent bond only. For nonpolar covalent bond, it is equally shared. But when it is unequally shared, we call it polar. We can take a look at the example of water. And before we take a look at the example of water molecules, we look at another term called electronegativity. Electronegativity is the term to describe the attraction of an atom for electrons. Some atoms, they love electrons so much. So some atoms, they love electrons so much that when they form a covalent bond with other atoms, they will have a tendency to grab the electron closer to themselves because they are electronegative, or they are highly electronegative. Some atoms, on the other hand, they don't mind, or they don't care. They don't like electrons too much. So if other atoms, they want to grab the electron closer to themselves, they'll just let it go. So they are less electronegative. So we first talk about nonpolar covalent bond first. For example, we have 2 hydrogen atoms forming a hydrogen gas. In this case, because they are identical, so their electronegativity, that means their tendency or the attraction for electrons should be identical. Because of that, the sharing of the electron will be equal. When they have equal sharing of electron, we call it nonpolar. On the other hand, this is like an extreme case. Carbon atom is very large in compared to hydrogen. Because if it's larger than hydrogen, then it is more electronegative. When it's more electronegative, it will have a tendency to grab the electron closer to itself. In this case, all these shared electrons will be getting closer to carbon. But we still call methane gas as a nonpolar molecule. Why? The reason is that, remember the tetrahedral structure here. The tetrahedral structure here will equal out or balance the electronegativity. What happens is that, yes, carbon is more electronegative than hydrogen. And yes, carbon will hold more electron closer to itself. But because of it has 4 hydrogen atoms that equally in an equal distance that balance out the charges. So that's why it will be cancel out the differences between the hydrogen atom and the carbon atom. The arrangement of this tetrahedral shape will cancel out the differences of the unequal sharing of the electron. In this case, it will make it nonpolar. So what are some of the examples of the polar covalent bond? When the sharing between the electron is unequal, then we have a polar covalent bond. We'll give you this example of water. Water, as we know, that it is H2O. So oxygen is a very big molecule, a very big atom compared to hydrogen. You can think about the situation, it's like bullying in high school. Oxygen is big guy, that's why you can bully the small guy, hydrogen. So remember in high school bullying, what did the bully usually do? Bully, they usually take the lunch money from the weaker student, right? In the same situation, the bigger oxygen bully will grab the electron from the hydrogen closer to itself. So the electron, they are like the lunch money. So hydrogen, because they are relatively small size, they cannot get hold of the lunch money, so they will just let go. Okay, you take it, fine, you don't care. When oxygen has grabbed more electron to itself, what will happen to the charge? We can draw it out in this way. Oxygen, and then it has 2 hydrogen like this. Because oxygen atom is a bully. It is more electronegative. It loves electron more. So the sharing of the electron will be closer to the oxygen. That will make oxygen slightly negative. How do we represent slightly or partially negative? We use the Greek letter delta. Greek letter delta here means slightly or partially, and then negative. Because the electron is unequally shared, because the hydrogen is smaller and weaker, you let go of the electron and let oxygen take it. So hydrogen atom, they will become slightly positive. As you can see in here, one end of the molecule is slightly negative, and the other end of the molecule is slightly positive. So we have 2 opposite charge on different ends of the molecule. Therefore, we call that polar. We call the water molecule as a polar molecule. Hydrogen bond. So we talk about ionic bond, covalent bond. The third type of bond we want to talk about is hydrogen bond. Hydrogen bond, I can tell you this right now, is the most important bond in living organism. A lot of our properties in the body, they are based on hydrogen bond. We will talk about it now. But before that, what is a hydrogen bond? Basically, the hydrogen bond is the attraction between the delta negative oxygen and delta positive hydrogen. But we are not talking about here. We are not talking about this bond here. The bond here is a covalent bond. The bond here is covalent bond. We are not talking about the difference between the two. We are talking about the difference between water molecule. Meaning that if you have another water molecule here, which is slightly positive again at the hydrogen atoms, and slightly negative at the oxygen atom. We are talking about the attraction between water molecule. That means here. Because it is slightly positive at the hydrogen atom and slightly negative at the oxygen atom, this slightly oppositely charged will have the attraction. And we call this attraction hydrogen bond. So remember the differences. Covalent bond is between atoms, between oxygen atom and hydrogen atom in this case. Hydrogen bond is between molecules. It's between one water molecules and another water molecules. It is between two molecules. This is a good point here. Hydrogen bond is weak. Individually, if you compare this straight line covalent bond with this dotted hydrogen bond, this is a lot weaker than this one. But if you have a lot of water molecules together, then you have a lot of hydrogen bond forming. Then a lot of weak hydrogen bond together, it will become strong. We'll talk more about this property in the next few slides. So this is just a summary of what I just told you here. This is a water molecule, slightly positive at the hydrogen atom and slightly negative at the oxygen atom. And in between the water molecule, we have hydrogen bond. And it's just the same. The chemistry of water is important. The reason is that scientists believe that the first cell evolved in water. And that's why when NASA sent the land rover to Mars, one of the tasks of the land rover is to search for evidence of water in Mars. Because if there's water in Mars, it means that Mars can have life. Maybe it's just a bacteria, maybe it's just a single cell organism, but still we have evidence that that Mars can have life. That's why water is important to have life. Second point is also important because living organism, most of the living organism on the Earth composed of mostly water. And the rest of the point we already talked about is water is polar molecules. Water forms hydrogen bond. And water is liquid, of course, we all know that. In a normal situation, in a normal temperature. The first property we want to talk about is the heat capacitance. Water has a high heat capacitance. What does it mean? Heat capacitance means that how much energy we need to supply to water in order to raise the temperature of water. Water has high heat high heat capacity, meaning that water requires a lot of energy to supply to it in order to raise the temperature. The first bullet point is a definition of calorie. Calorie is the amount of heat energy needed to raise the temperature of 1 gram of water for 1 degree Celsius. The reason why it takes a lot of energy to raise water for 1 degree Celsius because of the hydrogen bond. In order to raise the temperature of water, we must supply enough energy to break, or I would say partially break, partially overcome the hydrogen bond. But you may ask, hey, how come you said that hydrogen bond is a lot weaker than covalent bond? How come we still need to supply a lot of energy to water? Well, I also mentioned that in water we have a lot of hydrogen bond. When you have a lot of weak hydrogen bond together, then it makes it very strong. That's why we need to supply a lot of energy to overcome all these weak hydrogen bond in order to raise the temperature. One of the resulting properties is that living organism like human being, because we compose of mainly water, then we can keep our body temperature relatively at a constant level. That's why we call ourselves a warm-blooded animal, or we can call ourselves endotherm. Another application of this is that, have you noticed that the housing price along the beach houses, they are a lot more expensive than houses, let's say in the inland? Have you thought about why? I remember I asked this question to my Bio 3 student in El Camino College. They gave me the answer. They said, oh, because it has a nice view. Then I asked them, okay, what do you mean by nice view? I asked them, do you mean the view of the ocean is nice, or do you mean the view of the beach? You can see a lot of beautiful women in bikini. That's why it is a nice view. And then my student told me both, and they think that having a nice view in the beach houses cause the price of the housing of the beach houses become very high. Actually, it is not the reason. The main reason, because of the heat capacitance. If you live close to the beach or close to the ocean, because the ocean has a lot of water, it can trap a lot of heat. Water, as I mentioned, it has a high heat capacity. The high heat capacity of the ocean will keep the temperature in the coastal area relatively constant. So the fluctuation of the temperature in the beach houses will not be that much. That makes people living in the beach houses very nice and happy. On the other hand, if you get a house in the inland, like most of us do, then because it is farther away from the beach, from the ocean, from the water, then the fluctuation of temperature will be larger and will be quicker and easier to change the temperature. Then we will have to use something called AC, air conditioning, to keep the temperature relatively constant in summer, let's say. Or we need to turn on the heat in winter. Because in the inland, we do not have the ocean, which has a high heat capacity to regulate the temperature. And now you know why the real estate along the coast area is so expensive. Another property is the heat of vaporization. Heat of vaporization is very similar to the heat of capacity. In here, heat of vaporization meaning that how much energy we need to supply so that we can convert liquid water into gaseous water, namely the water vapor. It's like how much energy we need to supply to so-called boil the water into water vapor. In here we say that water has a high heat of vaporization, meaning that we need to supply a lot of energy to water so that it can become a gaseous state. In here we give you a number. We need 540 calories to convert liquid water into gaseous water. An example we give you here is sweating. The reason why sweating can lower our body temperature because of the high heat of vaporization of water. When we're sweating, we have a thin layer of sweat, mostly water, on our body. And as our body temperature is getting higher and higher, and also the surrounding of our environment is hot and windy, then it will help to evaporate the sweat on the surface of our body. When the sweat of the surface of our body is being vaporized, then what will happen is that it will absorb the heat energy on our body. When the heat energy of our body is being absorbed, then it will lower our body temperature, and it will make us feel cooler when we sweat. And the second point is basically I already told you why the beach houses, they are more expensive. The third property of water is that water is a solvent. Many textbooks actually put one more term here, is a universal solvent. We use water to dissolve most of the chemicals that we know. In here it says it dissolves many chemical substances. We call it universal solvent. When water dissolves substances, the dissolved substances, we call them solute. For example, if we add salt into water, then we call salt as the solute. Similarly, if we dissolve sugar, glucose, into water, then glucose will become the solute. Then I want to introduce two new terms, hydrophilic. Hydro means water. Philic means love. Hydrophilic molecule attract water because hydrophilic molecule means it is a water-loving molecule. Of course, if it is a water-loving molecule, it will attract water. Hydrophobic. Hydro means water. Phobic means fear, like phobia. It is a water-fearing molecule. So these molecules, they don't like water, so they do not attract water. You can substitute attract with, like the term dissolve, or like the term mix. Hydrophilic molecules, they can mix well, or they can dissolve in water. Hydrophobic molecules, they cannot dissolve in water, or they cannot mix well with water. An example of hydrophilic molecules are table salt, sodium chloride, glucose, or alcohol. You know that you can dilute your beer in water, but no one wants to do that. Or hydrophobic molecules. What are the examples? Like oil. You can never mix oil with water because oil, they are hydrophobic, they don't like water. Here, this is an example of how water dissolves salt. I mentioned that when you salt sodium chloride, they are hydrophilic. What happens is that the positively charged sodium ion will be attracted to the slightly negatively charged oxygen atom. And the water molecule will surround the sodium ion with the slightly or partially negatively charged oxygen atom, just like this. Because as you know that opposite charge attract, by surrounding the sodium ion with water molecule, the sodium ion can be being pulled away from the chloride ion. In this case, the ionic bond will be broken. Similarly, the chloride ion can also be surrounded by the slightly positively charged hydrogen atom. When the chloride ion is completely surrounded by the slightly positively charged hydrogen ion, chloride ion will also be being pulled away from the sodium ion. So the ionic bond is being broken. I like to compare this situation, the dissolving of salt into water, as if they are getting a divorce. Why? Because sodium ion is having an affair with, well, a lot of water molecules. So because of that, sodium ion leaves his wife, chloride ion. So when the ionic bond is being broken, so it's like getting a divorce. As a revenge, the wife also surrounds herself with a lot of water molecules, like having an affair with other guys. And the wife also broke the ionic bond with the sodium ion, so they are like getting a divorce. Next property is cohesive and adhesive. Cohesive, when you see the term start with CO, meaning that it's like with the same or similar group together. In here, cohesion is the attraction between water molecules of the same one. Adhesion, meaning that on the surface. And adhesion usually occurs between water molecules and different molecules or different surface area. For example, in here, the hydrogen bond between water molecule, we call them cohesion. When you dissolve water, when you dissolve salt into water, the attraction between water molecule and let's say sodium ion, here we call that adhesion. Similarly, the attraction between the water molecule with the chlorine ion, we also call that adhesion. Here I give you an example of where you can find cohesion and adhesion. Is the transporting blood in our body. But I want to give you two extra examples I think is more relevant to your daily life. One is paper towel. So after you do number one, I hope that everyone will wash their hand. And after you wash your hand, then you need a paper towel to dry your hand. So have you noticed that the paper towel can absorb water? But have you ever wondered why? How come the paper towel can absorb water, but let's say your tabletop cannot absorb water? The reason why a paper towel can absorb water because paper towel is made of a lot of fiber crisscrossing each other. When all these fibers crisscrossing each other, it forms tiny little space in between them. These tiny little space can trap water. And water is being trapped by cohesion and adhesion. Water molecule can adhere, stick to the fiber, but they will also attract to each other so that you can have your wet hand or the water can be absorbed by the paper towel. As a matter of fact, if you dip this paper towel in a cup of water, you can see that water will continuously to sip upward, to move up. It is because of cohesion and adhesion properties. And another example that you will learn in Bio 3B later in this semester is that in plant, there's a vascular system called xylem. Xylem is like a tiny little tube inside the stem of a plant. It transports water from the root all the way to the leaf in the stems. And this tiny little tube, you can call it capillary or capillary. They have the capillary action. Capillary action is basically cohesion and adhesion. So water molecule, they will stick to each other by the hydrogen bond, cohesion. And water molecule will also stick to the surface, inner surface of the xylem using adhesion. In this case, water can be transported from the root all the way to the top, to the leaves, using this cohesion and adhesion. Water also has a high surface tension. It is due to a lot of hydrogen bond in between water molecules. If you do an experiment at home, very simple, you take a glass of water you take a glass and then you fill the glass with water until it is almost full, until it is full. And then you continue to add drops of water into the glass. Then you see that the water actually form like this. It is a glass. And then if you fill it with water, you can actually see that the water will actually go outward like this. And we call it surface tension. The surface tension here, you can actually put a coin. The surface tension of it may or may not work. Let's forget about the coin. Yeah, some people, they claim that they can actually flow a coin. You can actually put a coin on the surface and then it can still be on top of the water instead of sinking down. But some people are able to do it, some people cannot. One practical example they can do at home is that you can set up a fly trap. I would say an environmentally friendly fly trap. How do you do it? You can also use a glass, a cup, whatever, a container. And then you pour in apple cider. Apple cider, normally if you put it in the open air, you attract a lot of flies because they like this sour smell. It reminds them of eating the fruit. So they flies will have a tendency to go to the apple cider to drink it. But then, the trick is that you add 1 or 2 drops of dishwashing detergent or hand washing detergent into the apple cider. You don't need too much. Normally, the flies, they can stand on the water surface or on the surface of the apple cider when they drink it. But after you add 1 or 2 drops of the detergent into the apple cider, what will happen? When they try to stand on it, the flies will sink down to the bottom, just like a human being. It looks very funny and stupid when you do this, because you can see that, oh, they think that they are like Jesus, they can stand on water, but now they sink like human being. If you do this, if everything is correct, after a while you will see the dead body of flies at the bottom of the apple cider. So you can try this at home, and the reason is that the detergent breaks down the surface tension. It makes the surface tension weaker. And because of the surface tension is weaker, then the flies can no longer stand on the surface of the apple cider. Then they will all sink. Oh, this property of frozen water, this is important. Everyone will have this experience. When you get, let's say, a soda from McDonald's, you will see that the ice is on top of your soda. Why is that? We now explain to you why. When liquid water cools down, of course, all the molecules will come closer to each other. As we know that heat expand and then cold contract. So all the water molecules, they will come close to each other at 4 degrees Celsius. After 4 degrees Celsius, the water actually will expand. Why? Because at the temperature lower than 4 degrees Celsius, water molecules, they will form a crystal lattice structure. And this is how the ice is being formed. The crystal lattice structure allows the water molecule to maximize the space in between them so that they can keep the hydrogen bond formed. When you take a look at the picture in the next slide, you can see that in here, the water molecules, they separate away from each other with a lot of space in between them. They form a hexagonal structure here, and so that they can form a crystal lattice as an ice. Because of all these empty spaces in between the water molecules, and in comparison to liquid, which is they are randomly arranged, all these empty spaces make the density of the ice a lot less than water. And that's why water can flow on top of, ice can flow on top of water. on top of liquid water because it is less dense, as I shown you in the slides. It has a lot of empty space in the ice. And because of that, in winter, let's say if you're in Alaska or Nebraska, the very cold weather, what will happen to the lake in those areas? The lake or the ponds, they will start to freeze. But the freezing of the lake and the pond is top down, from top to the bottom, which is a good thing. The reason is that after the ice is formed on the top, it actually helps to insulate the temperature of the lake at the bottom, so that all the fishes or living organisms at the bottom of the lake, they can still live in a relatively warmer temperature of water. In this case, it won't kill all the living organisms during winter. So this figure, as I showed you before, the ice has a lot more empty space. Liquid has less. That's why liquid has a higher density than ice. This is the curve. The density of water continues to increase when the temperature drops to 4 degrees Celsius. After 4 degrees Celsius, when the crystal lattice is formed, then the density of ice drops dramatically and stays at the same level. Last topic is acid and bases. Water, as you know, that it is formed by covalent bond, but water can be, we call it dissociate, or you can assume that it is broken down into ions. From a neutral atom, it can become a charged ion. So water can, we call it dissociate into hydrogen ions and hydroxide ions. And we have this reversible arrow, meaning that this dissociation is a reversible reaction, meaning that water can, a neutral water molecule can become a charged hydrogen ion and charged hydroxide ion, and this reaction can also go back from charged ion to become a neutral molecules. How do we define acid? Acid is the solution that has high hydrogen ion concentration, or is the substances that release hydrogen ions. See, dissociate. For example, when we dissolve HCl, hydrochloric acid, into water, HCl will dissociate into hydrogen ion and chlorine ion. Because it will dissociate into hydrogen ion, it releases hydrogen ions that we call hydrochloric acid as an acid. This chloride ion is the same chloride ion you can find in your table salt sodium chloride. Basic solution. How do you define base? It is the solution that has a low hydrogen ion concentration. In here, the first bullet point, it gives you two definitions. One is that it will release hydroxide ion. Another definition is that you will take up or absorb the hydrogen ions. We give you the example of the first one, releasing hydrogen ion, is the sodium hydroxide. When we dissolve sodium hydroxide into water, sodium hydroxide will dissociate into sodium ion and hydroxide ion. So it fits the first definition, you will release hydroxide ion. Remember, this sodium ion is the same as the table salt sodium ion. For the pH scale, I hope that you remember, for pH less than 7, it is acidic, because we have more hydrogen ion than the hydroxide ion. If pH is above or more than 7, then it is alkaline or basic, because hydroxide ion, we have more hydroxide ion than the hydrogen ion. The bracket here means concentration, meaning that, okay, in here, the concentration of hydrogen ion is larger than the concentration of hydroxide ion, meaning that we have more hydrogen ion than hydroxide ion. If pH is 7, that means it's neutral, meaning that we have equal amount or equal concentration of hydrogen ion and hydroxide ion. We can take a look at these pictures here. We have the scale. Our stomach acid is highly acidic because we have stomach acid is mainly composed of hydrochloric acid. The one that I want to bring you the attention is human blood, because human blood here is off the scale. In here it is almost like 7.8 or 7.9, but in fact human blood is around pH 7.35 to pH 7.45. Remember this? The pH of our human blood is between 7.35 and 7.45. Last but not least, we want to talk about buffer. Buffer is a chemical. I'll define buffer as a chemical or solution that resists the changes of pH. And it helps to keep our pH within normal limits. So we give you an example, bicarbonate ions or carbonic acid. Our blood has these two bicarbonate ions and carbonic acid in our human blood. And they are the buffer. They help to keep our blood pH at around 7.4. These two are the chemical reaction. Let's say if our blood is a little bit too acidic. For example, when we are doing exercise, when we have a lot of carbon dioxide accumulated in our blood, dissolving carbon dioxide in the water will make the solution acidic. When we are exercising and we produce too much carbon dioxide, then we will have excess of the hydrogen ion in the blood. Then the bicarbonate ion can absorb this hydrogen ion to form carbonic acid. And this absorption of the hydrogen ion is the second definition of the base. On the other hand, if our blood is becoming a little bit more basic, that means we have a lot more hydroxide ion in our body, in our blood, then the carbonic acid can neutralize it to form water molecules and also the bicarbonate ion. Because of these two reactions, it helps to keep our blood in a relatively stable pH. So that's it for today's lecture. Please feel free to ask me questions on our Wednesday night lecture if you have any question about tonight's lecture.